Okay, good morning, everybody. Thanks for joining us today. And I'm delighted to welcome Marie Soressi today as our speaker. Marie did her PhD at Bordeaux. Then the first time we met when she had a postdoc in the Max Planck Institute for Evolutionary Anthropology in Leipzig, where she stayed for quite some years, and then moved on to a position at the INRAP in France before moving to her current position at the University of Leiden at the Faculty of Archaeology, where she is now a professor for archaeology, I guess. So thank you very much for joining us today, Marie. And we're looking forward to your talk on excavating Homo sapiens interactions with Neanderthals. Thank you.
Thank you. Thank you very much, Philippe. It's a pleasure to be with you this morning, to be welcome in Vienna, in sunny Vienna. So I'm going to take you back to the deep past. And of course, as archaeologists or paleoanthropologists, we are fascinated by this deep past, and our focus is on reconstructing the identities, the lifestyle, the habitats of those ancient humans. But one of the problems we have is that we don't have one of those fancy time machines. And here I put two of them, the one from when I was a teenager. Maybe some of you remember that one, the one on the right. And the one that is nowadays on Netflix, which is this one. Anyway, this is our time machine. So our time machine is our excavations and everything we can learn from it. The problem is that, of course, our time machine gets us to a place where what is preserved, what we have access to in that place, is influenced by a very long history of taphonomical and post-depositional processes. These site formation processes and the taphonomic modifications of organic remains are plentiful. And not only there are those biological and geological processes that are modifying, altering, transforming, moving, transporting the original remains of the humans from the past, but also we, as archaeologists, we are also imposing on the past what we do, starting from the excavation. And how do we do that? Mainly and mostly because we need to create assemblages. So not only there are those formation processes that transform something that is very bright and very crisp into something that becomes less bright, more fuzzy, and, well, eventually completely lack many things. But then from that, we create that. So we go from many things to 3 or 4 assemblages. And when we are lucky in those assemblages, well, we do, in those packages that we make, we also have stone tools, human remains, faunal remains, all sorts of different remains. So when we are in a situation when there is, for instance, those 2 individuals, and looking at one artifact, manufacturing maybe one artifact, and we find 1 human remain and 1 artifact, we are actually quite fine. But the problem is that one. It's when the original assemblage was created by so many different people, and then when we study it, we actually, it's extremely difficult to tell if that tooth represents the variability of those people, and if this, and who manufactured that artifact. So the palimpsest we have to deal with can be fine if we are in that type of situation, and can be almost extremely difficult to deal with if we are in that different situation. And when we are in that second situation, so lots of things happening and very little things left compared to what happened. So a long palimpsest, or a palimpsest of many people with many different activities and very little remains. Then what we are at risk to actually create chimeric assemblages. So combinations of different things that were deposited by different people at different times. And here I like this beautiful horse with a goose face. And if it becomes a bit blurry and you see it from far away, well, you may think it's a horse. And if you see it even more from more far away, you may think it's a goose. But in fact, it's neither. So how do we do when we are in this situation and we still want to answer those questions? Who was there? What was this person doing? Were there interactions? Let's go back to our time machine and see what we can do. In this talk here, I'm going to focus on 4 different things, 4 different aspects. First, I'm going to talk about excavation and excavation techniques. Second, I'm going to talk and to mention the investigation of site formation processes and the importance of doing this in real time from the excavation onwards. Third, I will talk about detailed analysis of artifacts. And last, I will finish with the importance of the collaboration with the geneticist. So let's start with the excavation. And I'm going to start with that site that I excavated for 10 years. It is a site that is in France. It is named Les Cottés. And there is a long sequence. It's dated between 50 and 33,000 years old, 1,000 years. We abundantly published about that site. This is how it looks like. There are 14 meters of sections, which is pretty extensive. And the collections that we were able to excavate over 10 years are big. And the interesting thing is that it covers this time period from the Mousterian to the late early Auricnation. So in one site, we can see how behaviors changed with similar constraints, because the same space is used and the same materials are used. That site was actually used, one of the first sites where sedimentary DNA for deposit of that age was put in practice by Viviane Sloan and Matthias Meyer, and then published in 2017. I'm mentioning it because I'm going to go back to it at the end of the talk. Also, I'm mentioning it because also when this started, I thought that this is a very funny idea that would never work. And of course it did work, and much more faster than what I would have envisioned, being me, myself, of course, not being aware of the development in environmental DNA in biology. So one of the things that we were able to document thoroughly from the excavation was the way used to manufacture lithics, stone tools, in the Châtel-Péronian, which is this culture that we find around 43,000. And the culture that at that site is right above, a bit younger, 42, 41, that is called the proto-regnation. There are two completely quite different ways of producing stone tools in those assemblages. They both have interest in producing long-distance weapons, like this one. It's a reconstruction. And those weapons are tipped with what we call bladelets. Those weapons are extremely effective. To produce those bladelets, they use two different ways, and you can probably see it, because basically here the core is very rounded. It's a production that goes around the core that is convergent. Meanwhile, here in the Châtel-Péronian, the core is angular, and it's a production that goes around different plan surfaces. So different ways of doing things. And that, of course, we can say based on the thorough and very detailed documentation of those lithics. At the site I excavated, those lithics are one after the other. The Châtel-Péronian is preceding, is older than the proto-regnation, but we know that at a regional scale, those two cultures do overlap, and that there is an overlap of probably about 1,000 of years, maybe even more. And that we recently reevaluated it. And now you're going to understand why I am talking about this overlap, because at the same time we were excavating that first site, we started studying a second one that is 80 kilometers away from the first one, still in the center of France. That one is called the Quincay, and that site is a cave site was documented to have only Châtel-Péronian deposits. Circa 1 meter of Châtel-Péronian deposit, which is enormous. It's very thick. At Les Cottés, for instance, the layer is about 7 centimeters thick. So 1 meter of Châtel-Péronian is extremely thick. It's also one of the rare Châtel-Péronian sites where there are bone tools and personal ornaments. And the documentation of the old collection allowed Morgan Roussel to document, sorry, so the repetition, to document that there was this Châtel-Péronian way of doing things, Châtel-Péronian way of producing bladelets. However, in that specific site, where those bladelets were retouched So in the end, where they were finally, the final shape was given to those bladelets, was actually the same than the one used by the Proto-Auric nation. So at the time when we published those results, we actually realized that there were a different way of producing, obtaining the blanks, the bladelets, but at the end, they were retouched in the same way. So from that, what we suggested was the following, that those Châtelperrian people at Quincay may have been in contact at distance with the Proto-Auric nation people who were producing that specific shape of bladelets. And how would that work? By the simple fact that those bladelets are elements of weaponry used during the hunt, so elements that you can actually find in the landscape. This is one possibility. The other possibility that we suggested at the time, sorry, I'm going back too much, was that there was influence at distance, and that they were conservative and that they refused, even if they were in contact, they refused to adjust their manufacturing processes. So for us, that was one of the evidence of potential evidence of interactions between Neanderthals, that culture being most of the time mostly attributed to Neanderthals, and Homo sapiens. But the problem is that at that time, we had no knowledge of the sedimentation at the cave, of site formation processes at the cave, which pushed us to go back to the site and started excavating the site to better understand site formation processes at the site, and also to date it. And this is, so we started working at the site in 2020. We have documented it. In fact, there are lots of sections still available, 18 meters of section, which again is quite important. For now, we excavated very little. And the reason is that it is an extremely complicated site. It is severely cryoturbated. And you can see the movement of here. You can see the movement due to the cryo expulsion over there too. Here, for instance, you can also see the layers and their and the cryo expulsion of the artifacts. Here you can see that the artifacts are all standing. So of course, right away you can, by just simply seeing those pictures, you can understand that it is extremely difficult to excavate that type of site. So this is the way the previous excavator was doing it, was doing the excavation. They were excavating very small, actually they were excavating columns of 33 by 33 centimeters. And as you can see here, they were doing those columns across, I mean, they were taking it from the top and then going down. They went quite deep on each of those columns, crossing several layers. Of course, recognizing those layers, but going through. And of course, you can also see on this picture that the quality of the light was not perfect, was not so good. And even today, it's very clear that if you don't have, I mean, very good lights are extremely important. So this is one of the factors that, of course, we are lucky to have today, is that we have good generators with excellent LED lights, lots of them, which was not available at the time. And the other thing that we are doing is that we are not excavating like that in narrow columns. We are not excavating flat like it is often done, but we are actually peeling profiles. So this is what I try to say here by saying we are profiling. So basically, we are taking usually areas about 1 meter large, so usually actually a bit smaller, 50 to 60, and then we push it by maximum 15 to 20 centimeters, and usually it is less than that. And we do that to actually have an excellent control of what we are doing, and this is a focus we have every single day, every single hour. And here you can see how this works. You can see the type of gesture the person excavating is using. You see that she's using a tool vertically. And here the same. And we do that because this is really the only way to follow those layers that are doing waves like that. And the other thing we are doing is that we work extremely closely with geoarchaeologists who are on site, or at the site, on the site with us during the excavation. So there is, the whole excavation is actually geared toward recording and understanding and discussing what we are excavating. So this is what I meant and what I mean by real-time investigation, is that already when we are excavating, this is our focus. Of course, we continue working on this afterwards, but the work on site formation processes really start during the excavation. And of course, in parallel, there are many things happening. For instance, at the moment, we really want to try to understand better the influence of frost on the movement of artifacts. And one of my collaborators, Areti Leventi and Michael Baye, are actually working on this at the moment, reviewing what is known and then doing more experiments and controlled experiments with the reference of Quincay. Another thing that we do is that the sediment that we are taking, so we are piece plotting until 1.5 centimeters for lithics and 2 centimeters for bone. So everything else, when it's something non-recognizable, when it's not a tooth, for instance, when it's something not diagnostic, goes into the bucket, but the buckets are extremely small. You can see our buckets here. So often it's 0.3 liters of sediment in one bucket. Why? Again, it's to have the best, what the best we can do to have precise stratigraphic control. Here I put the picture of Harold Dibble and Shannon McFerron because this technique of taking buckets per area, with the area not being a fixed area, so meaning that it's an area that you adapt to the situation, is a very flexible system, and is a system that, to my knowledge, say, put together, and that actually allows to keep control of the stratigraphy in an easier way. Because basically there are no strict rules. So you go with what is needed where you are excavating. And indeed, in Quincay and in caves of that type, things are changing laterally all the time. So having this flexibility is very much needed. And of course, this sediment is then washed. We use a 2 mm mesh. It is water sieved. And from that, this is where we can actually retrieve those very small bledlets, of course. And it's clear that if you don't do the 2 mm mesh, you're going to lose things. And by the way, by doing the quantification of how much do we have in those in the sediment, we can actually see that the quantity of small finds we have throughout the layers at Quincay is actually logical and comparable to what we find in experiments. So it seems that by and large, we are not missing the fine fraction. So those are examples of what we are finding now with a new excavation. At the bottom, there is a Mousterian layer, which I described in the past, so this is no surprise. Above, there is Châtelperronian, well preserved. So this is also no surprise. But above, there is Auricnation. And above Auricnation, there is also probably, clearly from some artifacts, there is Gravation. So in fact, the sequence that we find is actually much longer than the sequence that was previously described. So unfortunately, there is a strong possibility that that excavation technique did conducted to mixing of artifacts during the excavation. And that I can say because up to now, and we need to continue, up to now, the assemblages we are recovering are simple, or if you may say, they are clean. So they are either Mousterian or Châtelperronian or Auricnation or Gravation, but there is no things in between. So considering the amount of effort and the quality of the lighting and the focus we have on excavation techniques, I think that we are going to be able to show, likely, that unfortunately what have been published before may be a chimera. We'll see. We still need to get more material and to increase our sample size. But I'm not very optimistic. And the time will tell us. So this is one example that I wanted to give you about the need to adjust our excavation techniques to put the focus on site formation processes from the excavation onwards, with everyone in the team, including every single excavator, in charge to reflect and to record and to document and to discuss site formation processes every day, every hour during the excavation, and then onwards. I'm gonna switch to a third site, if you may. A third site where I've been discussing the possibility of that I've been using in the past to discuss potential interactions in between Neanderthals and Homo sapiens. And that site is Pech de la Zéouane, which I excavated in 2024 and 25. It's a beautiful site that is a huge cave that is located in the southwest of France. You can see here a younger version of myself. When I met Philippe soon after, I think. This is how it looked like, the stratigraphy in the entrance of the cave. It's more than 3 meters of deposit. Everything is Mousterian. Everything is attributed to what is called Mousterian of Acheulean tradition. You can see right away that the stone tools have nothing to do with what we've seen before. It has been dated by OSL, single grain. It's a work by Zenobia Jacobs. I don't know why I don't have the reference here. The entire sequence seems to be around 50,000 years old. So very quick accumulation rate, probably with gravity playing a huge role here. It's an interesting site for several reasons. Maybe you haven't heard about this, so I mention it. It's one of those sites in southwest France. Actually, it's the site where a lot of those manganese oxide pebbles are found. Those are very small pebbles. This is you find those pebbles in nature. They have very high coloring power. As soon as you touch them, your fingers are completely black. They have been grinded to produce powder. It's clear they are covered with facets. There are more than 400 of them, lots of them. And in 2016, actually, in 2015, a master's student who was a chemist came to me and asked me how he could help me with his knowledge. And I told him that's something you can help me with, because at that time we had no idea how this manganese oxide could have been used and what properties could have been useful in the past, besides the coloring property. The coloring property, of course, was obvious. But if at that time, even going to the ethnographic record, there was no documentation in the ethnographic record about how those pebbles have been used in the past, how this powder may have been used. And this is manganese dioxide. So then the chemist told me, well, if it's dioxide, if there is oxygen in it, it may be of interest for combustion, to start a fire. And then he actually put together a series of experiments And then he did controlled experiments and controlled the measurements. And this is what he found. He actually found that if you use that powder and then you mix it with your wooden chips when you want to start a fire, actually, because of the chemical reaction that is happening, you do not need to go to the ignition temperature of wood is 460. If you mix it with manganese oxide, already at 300 and I don't remember, 20, I think, already then it started to ignite. So you need less energy to make it ignite. And then, of course, it is much faster. So it's an interesting aspect because, of course, it points toward fire production. Fire usage is a very old thing in human evolution. Fire production is something which, for now, there is little evidence for, and it's unclear if it goes back before, I mean, if it's earlier than the late Pleistocene. Here, it's well documented because of those, because of this material being used, and also because of that. Those bifaces show wear that is consistent with the usage as a striker light. So production of fire is the less costly hypothesis to explain those wear on those bifaces. So at that site, 50,000 years ago, it's clear that there was production at will of fire. Anyway, another extremely interesting discovery at that site during the excavation was this one, what is called a lissoir. A lissoir is a bone tool made out of rib of bovids, usually. The distal end of the rib has been shaped by grinding, and we were able to analyze the use wear on the tip of that one that is coming from Pech de la Zéouane. And it is consistent with the usage of those tools to soften hide. The interesting thing is that those tools that then were also found at another site that is called Abri Peyroni, and that was then excavated by Shannon McFerron. Those tools, when we discover them, they were only known in the Upper Paleolithic. They are everywhere in the Upper Paleolithic, and they are quite in the Upper Paleolithic of Europe. They are characteristic of the Upper Paleolithic of Europe, and nobody had found them in earlier times. At Pech de la Zéouane, remember that the stratigraphy is more than 3 meters high. It has been found here. There is only one at that site, and it was found here at the very bottom of the stratigraphy by us. So it was surprising to discover those bone tools. And it's even more surprising. I mean, a funniest story about those tools is that when I study them, I then realize that similar things are still in use. This one is one that you can buy on the internet. And actually here, I put one that was given to, loaned to me by my colleague, Josephine Jordens from Leiden. Her grandfather was a shoemaker in Amsterdam. And after he retired, he kept 3 tools, including that one. And it's the same type of material, the same shape, used to work leather. And today, I put this picture of one of those high fashion, expensive bags. Because today, in high fashion in Paris, they still use those tools. So it's a funny story because it's a tool that was already used 50,000 years ago and that we are still using. Probably because we haven't found anything better. Because the bone is resistant and soft and flexible, sorry, at the same time. So this is a unique combination to work leather and hide. When we published this paper in 2013, we suggested that there were three possibilities: either that those tools were independently invented by Neanderthals, or there were indications that modern humans started influencing Neanderthals earlier than what we thought. Earlier meaning 15,000 years at least earlier. And at that point in time, because there was nothing like that outside of Europe, we also wrote that because these finds clearly predate the oldest known age for the use of similar objects in Europe by modern humans, they could also be evidence for cultural diffusion from Neanderthals to Homo sapiens. So basically what we wrote, what we suggested, was that there was also an option for that, because that type of tool was completely unknown in Africa, completely unknown in the Near East, in the Mousterian. When Homo sapiens came into Europe, he may have learned it from Neanderthals because it was there with Neanderthals. And actually, it's very abundant in Western Europe also. The problem is that since then, at least one of those suggestions was contradicted by the facts. It seems that it's quite contradicted by the facts. There were similar tools, not exactly the same, but quite similar still, discovered in Morocco, in deposit older than 90,000 years. It's not exactly the same, but it's close enough, I would say. Before, we only had pointy bone tools, nothing like that. So that, and then the discovery in Bulgaria to a certain level, at 54,000 years in Bulgaria. For me, show that likely our suggestion that those lissoirs in the Mousterian could be evidence of Neanderthals transmitting something to Homo sapiens. I think those discoveries make this suggestion quite unlikely. Things would need to be studied more in details. Those spatula, for instance, it's unclear for what purposes they were used. But still, I think it's this suggestion that we made in 2013 is likely not the right suggestion. Also, since then, we also discovered that there is maybe Homo sapiens in Europe already at 200,000 years ago in Greece. And even more recently, the discovery and the publication of a modern human tooth in Mandrin in southeast of France and dated at 54,000. So our hypotheses, our suggestions were based on the fact that there were no modern humans in the area and that modern humans at the time of those lissoirs in the southwest of France. Well, for now, with the recent discoveries, it shows that our suggestions that those lissoirs could be evidence of cultural diffusion from Neanderthals to modern humans is probably a suggestion that is not likely, can be set aside. It remains that it could be independent invention, and it remains clearly that it could also be influence of Homo sapiens being present in the area at 50,000 years ago. So when we talk about interactions in Europe, we used to have several meaning a small number, but some indication of cultural interactions in France. I can think about 3 of them. 2 of them I just presented to you. The l'histoire from Pech de la Zéouane, our paper on Quincay in 2016 with the bladelets. Those 2 are now not so strong anymore. The last one is Arcis-sur-Cure. So this is to say that the number of evidence for cultural interactions that we have and that have been documented is very low, and now is getting even lower than what it used to be. Meanwhile, in the meantime, the number of evidence for biological interactions that we have is growing. Of course, those things are not directly comparable because the biological interactions are inherited. But still, it is quite interesting, I think, to observe that we have more and more biological evidence of biological interactions interbreeding. And at the same time, when we search for cultural interactions, we cannot find it. And I want to give you just a few other examples of how much detailed analysis of artifacts are needed if we want to continue to investigate those type of questions. And I just would like to mention very quickly, for instance, this work, which actually is publishing an industry that is extremely close to what was described at Mandrin. This layer where there is a modern human at 54,000. I mean, this is not a unique thing. There are similar things elsewhere. And this is a publication on the south of Italy that we did last year with Leonardo Carmignani. How did we find that? Well, it's just hard, tedious work on thousands of lithics. This is what it is. So very detailed analysis in order to be able to distinguish and recognize those different types of production. Same thing, tedious work at Beaudelot-Béziers in France by the same person, Leonardo Carmignani, who actually studied thousands. This assemblage is several thousands of artifacts. And in those thousands, there is actually bladelet. So it's an example where, again, with detailed analysis, well, things are found. But there is work to be done in order to find those things. Here, it's important because this is the oldest bladelet production described to my knowledge. With this type of documentation is abundant. There are more than 30 cores. And it is at least 30,000 years older than older than the oldest one before. And now to finish, yes, I think I would like to emphasize the need for close collaboration with geneticists. And I started to refer to it earlier in the talk. When the Max Planck geneticist came to me in 2010, I think, and asked me for samples, we actually discussed bone tools, retouchoirs, so tools used to nap, tools made out of bone used to nap. So the idea already was to try to extract human DNA from those tools made out of bone. I gave them samples, we discussed it, and they took samples. And at the same time, they asked me if they could take some sediment sample. And of course, I was like, yes, of course, we have cubic meters of sediment, be my guest, take as many samples as you want. But I was convinced that the sediment, the extraction of DNA, of ancient DNA from sediment, was just a crazy idea of them, and that it would never work. Of course, I was completely wrong, because five years later, I think they actually made it work. And by tailoring the techniques that were developing in biology, that were developed in biology. However, the work on tools made out of bone did not work. And it took much longer to make it work. And that is a study that we published last year, 2 years ago now, with a team. And we were able to put together a protocol to extract human DNA from osseous material, so either from teeth or from bone. And how does it work? Well, the principle is a little bit like the one of a washing machine, because when we wash our clothes, what do? We put it in the washing machine and then we turn the temperature. And then we also do something else, is that we add soap. And with that, with a raise in temperature and the soap, the stain on our clothes are getting free from the clothes. So here, it is a bit of the same principle, because the object is actually put in a bath with, and then the temperature is raised. And this is what was found. So the important object is here. This is what we want to look at. Over there on the top, you start with the sediment that is on the object. This is what S means, and P is the same, are pellets, so sediment detached from the object again. And you can see that, and then we go into the temperature, 21 degrees, 37, 60, 90 degrees. So if we look at that line here in green, this is DNA from Cervus. And you see that in the beginning, in the sediment on the artifact, there is a bit of Cervus, of deer in it. But then when you rise the temperature, well, the quantity of deer DNA is very important. Well, this is no surprise, because we are here testing and working with this canine of a wapiti. It's a wapiti. Wapiti is a big deer. So it is no surprise that when you put it in this buffer and you raise the temperature, well, then when you raise the temperature, you obtain deer DNA, because this is what the tooth is made of. But then the interesting thing is that one. Is here in red. This is the hominin DNA. And here, this is also the hominin DNA. Is that in the beginning of the process, you have no hominin DNA in the sediment, no hominin DNA in the first bath at low temperature. And then here, actually, in the sediment, a bit of DNA, of hominin DNA. And then nothing. And then it starts rising at 60 degrees. And then there is a lot of hominin DNA at 60 degrees. And this is that allows us to think that the DNA that was recovered is actually coming from inside the object. So this is because we retrieved it very much in the end of this process, so meaning at very high temperature, that we think that we are actually capturing the DNA of a person who has been handling, manipulating, maybe wearing this artifact. An interesting aspect of it is that this is a protocol that is minimally destructive because we are not sampling it, we are not making a hole in it. And we just put the object in a buffer. And we showed that by doing micro topography of the surfaces in the same place before and after. Actually, this is what helped to choose in between different buffer and to choose the one that was less aggressive. And at the microscopic level, but also at the macroscopic level, of course, this is the artifact after sampling and before sampling. And since then, of course, similar things have been developed by Thomas and his students for extracting collagen to do and for doing C14. So this DNA is the DNA of a female individual and is close to individuals found in Asia. This artifact comes from the Denisova cave, so all of that is logical and normal. And what is extremely interesting is that this is the first time we can actually directly link one object with one individual. So here, this palimpsest problem that we discussed previously is dealt with. Let's put it that way. So I do hope with this talk, I gave you enough information to convince you that, yes, indeed, there are certainly ways to work on those questions, and we can continue to be bold enough to be willing to address them. And that, from my point of view, to address them, we need to continue to invest in high-resolution excavations where site formation processes is the focus of the excavation before anything else. When this focus is integrated by everyone in the excavation, by every single excavator, I hope I have also shown you the interest of investing in detailed analysis of artifacts. And of course, when it comes to the future of ADNA analysis on artifacts, there is certainly a lot of things to be developed. There is still a lot of things to be tested. The study that I showed you is still a pilot study. Those things need to be done and done at many sites. And in order to do that, our excavation techniques also need to be adjusted. So there is a lot of things to be done. And with that, I hope that you enjoy this talk and that you gain some information from it. And I'm ready to answer your questions if you